Okay, today we're going to be talking about translations. This whole next chapter is about transformations, which is all about moving objects and distorting the image some way. Again, transformation is something we do to result in a change of position, shape, or size of the figure. My pre-image is going to be my original figure. My image is going to be my final figure. This rigid motion is going to be a transformation that preserves distance and angle measure. And when I say distance, I'm going to talk about side lengths. So again, this first one I'm looking at it, pre-image to image, my side length changes, so this would not be rigid motion. A and B both here would both be yes because my angles are staying the same. And the size of my image is also staying the same. So the first is not, the second two, though, are rigid motion. When we're talking about arrow notation, we're talking about transformations. The order matters, so my E is going to apply, or is going to map to my E prime, F to F prime, G to G prime, and H to H prime. Just like I have here in this image over here. When I move the whole thing, F is going to correspond to F prime, G to G prime, H to H prime, and E to E prime. And so when I'm mapping them, again, my arrow's telling me that I'm going from, this is my pre-image, this is my image, I'm going from one to the other. Translation is going to be a transformation that moves all of my points, same distance, same direction. So I'm just moving my image. This is the way that we're going to write this. So I have my capital T for my translation. My pre-image is going to be this triangle ABC. My image then, once I do my translation, will be my triangle ABC prime. My translation is rigid motion, so that means that all these side lengths will be the same. So all these are the same. All my angles are going to stay the same between the translation. And then the length in between. So the length that I move these guys, that will also stay the same. So my two triangles don't change in size, and then the length that we shift them in our translation will be the same. Writing a rule to describe a translation. This capital T again stands for my translation. This X is talking about horizontal movement. The Y is my vertical movement. ABCD is my pre-image. ABCD prime is my my final image, or my image. So what I can do is I can go over here to this graph and I can say I'm going to start at B and I want to find out how to get to my corresponding piece, which is B prime. So horizontally I move 1, 2, 3, 4 to the right, which would be 4 in the positive direction. And then I'd move down 2, which would be negative 2 vertically. So my translation, I move 4 in the horizontal direction and negative 2 in the vertical direction. And this maps from A, B, C, D to A prime, B prime, C prime, D prime. So this is the way that I write my rule. If I want to write my transformation for what's occurring here in the other side, or in this this graph, this translation, this would be the way that I would write my rule. Same thing over here. Again, I'm going to go from P to P prime. I could do Q to Q prime, R to R prime, S to S prime, it doesn't matter. But I'm going to go from P to P prime, so I go to horizontally 1, 2, 3, 4, 5, 6, 7, 8. So I move 8 positive horizontally, and then down 2, so 2 in the negative direction. So again, translation, I go 8 to the right, negative 2 down, and this is PQRS, right? Yeah. PQRS is my pre-image. PQRS prime is my final image. So if I'm given a pre-image, just like I have here with triangle PQR, what I can do is, given a rule like we just wrote, I can find out what my post image is going to be, or my image is going to be. Again, this -2 here is talking about my x. So whatever my x-coordinate is, I'm moving 2 to the left, or subtracting 2 from my x-coordinate. And then my y is -5, so I'm going down 5, or I'm subtracting 5 from whatever my y-coordinate is. So two ways I can do this. I've got my ordered pairs here, 3, 3, 2, 1, and -1, 3. And so one way I can do it is I can take each of these coordinates and I can go, well, p prime, q prime, and r prime will be 3 ordered pairs that I'm going to subtract 2 from the x and subtract 5 from the y. So my p is ordered pair 2, 1, so I subtract 2 from my x, get 0, subtract 5 from 1 and get -4. My q over here, 3, 3, subtract 2 from my x, I get 1, subtract 5 from my y and get -2. And my r, which is -1, 3, is -3, and then -2. And another way that I can do this is if I didn't want to do all that, all the calculation or whatever, I could just start at one point. So I'm going to start here at q, and I'm going to go 2 to the left and down 5. 1, 2, 3, 4, 5. That would be my q prime. Starting at my p, I would go left 1, 2, down 1, 2, 3, 4, 5. Right there, that would be my p prime. And then my r prime would be starting here, go left 2, down 1, 2, 3, 4, 5. That would keep all of my, again, they're still going to be the same shape. I've moved it 2 units to the left and 5 units down. And then the last one here, oops, no, I didn't want to do that. This one. When I'm composing 2 different translations, or 2 or more, this first translation tells me I move 4 right and 4 down. The second one says 2 right and 2 up. So if I'm just looking at my x's here, if I'm moving 4 right and 2 right, that would be the same thing as going 6 right. If I look at my y's here, I'm going 4 down and 2 up, so total that would be like going 2 down. The example they give us, they say that my pre-image is going to start at 0, 0, and so if I move from 0, 0, I add 6 to my x and subtract 2 from my y, that will give me the ordered pair 6, -2. And it's demonstrated here, where I start right here with my bishop in this chess game. They've mapped it out as going 4 right, 4 down, and then going 2 right, 2 up. What I can also do is just go 1, 2, 3, 4, 5, 6 right, and then down 2, and this is the ending spot that I get at. There we go.